Hey Grant, I'm going to give you an overview of what we're sending you and a little bit about this pump, and we're going to turn it on so you can listen to it. Okay, so you're going to get the new pump. Obviously, I've got a reservoir set up here, and I'm going to put some water in it to simulate your radiator, the sump in your radiator. Now, as the water goes in towards the pump, in the lines you can see the nice big air pockets in there, which is something you're going to have to deal with when you do this. I'll show you how this works pretty well. Okay. I'm leaving the top off of this so that it allows the fluid to suck in through. Basically, the first thing you're going to have to do is get your pump off of there. So what I recommend is that you drain it by connecting the tube that I gave you to the top of the radiator, turning the computer completely upside down if you need to, and let that drain out. Now, unless you crack one of these lines, it's going to take quite a while to drain it out because you don't have an air inlet to relieve the vacuum in the system, so it's going to take a while to drain out. If you're going to crack one of these lines, be very cognizant of where you're cracking it. What I recommend you do is you take these 4 screws out that hold the block on after you disconnect your wires. So this way you've got a little bit more latitude as to where you're pointing these tubes. You want to get as much water out before you disconnect them, obviously. You know, you can turn the computer completely upside down, hang it over a table, have someone hold it, and crawl underneath there and get it so that gravity will drop that water down to the floor and it can't go near the motherboard. You don't want to flood the motherboard or graphics card. A lot of times I will take something as big as a beach towel and I will put it over the graphics card, or sometimes I'll even take the graphics card out. But the point is I don't want water on my motherboard. So at any cost, try and avoid that. Once you get this disconnected off the CPU, you can get it up out of the way. Now what you can unscrew these connectors, these compression fittings, and wiggle the hoses out. What I find to be actually a little easier, because I don't like to sit there and fuss with this, I'm giving you lots of extra tubing. This is the same tubing that's in the computer now. It's super thick. It's the super clear kink-free tubing. I'm also giving you a tubing cutter. And the tubing cutter is set up so that if you want to, once you get the water out of these lines, you just snip the damn line and get it out of your way, you can. And this works real easy. You just put it in there, clip it. It gives you a perfectly straight, smooth edge. That way when you're putting your new line on, it lines up perfectly. So there's that. So when you connect your new pump, a couple of key points. Once you get your tubing connected onto this, and once you get your pump ready to mount, actually before you mount your pump, I'm including thermal paste remover and a prep material. So what you want to do is you want to take this and put the thermal paste remover onto a lint-free towel and use that to wipe the thermal grease off your CPU. And once it's completely clean, you can prepare the surface with this. It's a surface purifier. Use this on the CPU and on the pump. A note about your CPU. When you take this pump off of your CPU, you're going to notice that your CPU is a big copper block because your CPU has been delidded and lapped. I replaced, on all my Skylake chips that I use in my systems, I replaced the Dow Corning thermal interface that Intel uses to join the die to the IHS, and I replace it with liquid metal. Actually, I replace it with Thermal Grizzly Conductonaut, which has a thermal conductivity almost 10 times as much as the Dow Corning material. That's why we can get overclocks with low temperatures. If we didn't use that, if we didn't delid them, we would be limited to overclocks in the 4.2 range, and we'd be hovering in the 80s and low 90s. Now, the lower we can keep the temperatures on the CPU, the longer it's going to last. So the idea that we can overclock it to 4.6, 4.7 and keep our temps in the 70s, that's why we delid. So when you go to put your new block on, I'm giving you this. This is Thermal Grizzly Cryonaut. This has the highest thermal conductivity of any paste on the market today. It's at 12.5. The next best material is at 8.5. So it's a little pricey, but it's worth every penny. You can use it on that. However you want to put the thermal paste on your CPU is entirely up to you. Some people do the grain of rice, some people do the line, some people do the crossed. It's not going to matter much because of the fact that your CPU has been lapped absolutely mirror flat. So whatever you put on there is going to be basically squeezed out by the pressure mounting the pump on there. Here is an example I downloaded from the Arctic website, which shows, this is the method I actually use. I use a line. Now, here's the little triangle corner in the bottom of the CPU to give you orientation. Basically, it's from the top of your CPU or the top of your case down, and that follows the die inside. So I make a line about a millimeter, millimeter and a half wide from top to bottom, and when I put on my pump, because my CPU is dead flat, most of it just squeezes out to the side, and you end up with almost just a micro thin film of thermal paste, which is what you want. The less thermal paste you have between the IHS and the cooler, the better cooling you're going to have. That's why we lap them. So that's that. I'm just giving you some background info. I'm also giving you concentrated coolant. This is the same coolant that you got with your system. It's fantastic. I use this on all of my systems. It's the longest lasting stuff I've seen. But this is concentrate, so each bottle will produce a half a liter of finished fluid. Please use distilled and deionized water. Well, distilled water is deionized anyway, but deionized, it has no minerals in it and no metals, and it's distilled, it's clean. So use it with this material and you'll be good. You should have one extra bottle, put it in a drawer somewhere the next time you want to clean your system. Of course, it comes with instructions, which nobody reads, and it comes with a couple of these little plastic inserts that you can put so you can change the color of the LED if you so choose. Right now it's green to match your fluid. When you go to connect this pump, the pump comes with what's called a Molex connector, and here's your fan sync cable. So the Molex connector is going to plug into your power. Now, on some of the computers I build, if I don't have other devices that require a Molex connector up in that part of the case, but I have everything that takes SATA connectors, I'll snip this off and I'll put a SATA connector on it. I did not note on your system whether or not I did that. So what I'm doing is I'm including a Molex to SATA adapter that I made up. It's just it's sheathed. It just clips right in, and now you can go with SATA. So if you've got a Molex in your machine that connects to this, you're done. If you've got a SATA in your machine that connects to this, you simply use this adapter. Either way, you're done. I don't want you to get caught sort of shorted on that one. Now, before you start your pump up, you want to use this cable that I gave you. So let's say you've got your new CPU. Your pump is mounted on your CPU, and you've got water in your radiator. You've got air in your lines. See, you have an advantage over me right now, because with your setup, you can tilt and tip the computer, provided you make sure that before you tilt and tip your computer, and I'm giving you this from empirical experience, make sure you put the cover on the top of the radiator for obvious reasons. But let's say you can tilt and tip your computer and get the air out of these lines. I'm at a little bit of a disadvantage. So what I'm going to do, I'm going to drop my pump down a little bit, see if I can get a little bit more of this air out of the lines. Okay, but see, this is cool. I've got a big pocket of air here. This is going to prevent my pump from actually sucking. This is where the liquid goes in, and this is where the liquid goes out. So this air pocket is going to prevent my pump from feeding correctly until we get that air out of there. And the way we're going to do it is pretty simple. So I am going to connect my Molex connector, and I am going to use my cable. Now on your setup, let me set this back here. On your setup, this is the cable that connects to your motherboard, right? It's got a clip on it, so you want to depress that clip to get this off the motherboard. I like to jiggle it a little bit. Don't just pull this wire, because obviously you know your way around the computer. I don't need to tell you this. Take this off the motherboard, and then on the cable that I gave you with a switch on it, it has a little key up here on top that mates up with that clips in. And now what will happen is when you turn on your power supply and you have this power button, you're going to be just adding power to your pump and a couple of your fans. You're not going to be adding power to the motherboard, so you don't have to start the computer. This way you can toggle that pump on and off. You could also do it, if you just did a block, you could also do it from the power supply. This is just a bit more convenient. So you can control the pump on and off without having to have the computer committed to a complete start cycle. So I'm going to I've got a funky test power supply here, and I'm going to plug my cable into my power supply. My power supply switch is now turned on, but my power supply isn't lit because I don't have this switch in the on position. Once I turn this on, it's going to supply power to my pump. So I'm going to do what I call a shock it. I am going to zoom in so you can get a better idea of where this air is. By the way, this is my workshop. We're solar. We are off the grid. I use daylight whenever I possibly can. Right now it's kind of an overcast day. We had some snow. The sky is all gray. We have a massive battery bank on our solar system. So my LED lights in the house or in the lab are all running off batteries today because we just don't have enough sun to run everything. So there's So here we go. We're going to turn on the pump, shocking it a little bit. You can see that. Okay. You see that air bubble floating around in there? We need to get that out of there. You see how see the water? Can you see the water in this reservoir here? No. Let me show you that. Okay, you see it start, you see the pipe coming up through the reservoir? That's where your water's coming in. Now as air comes out of that, it's going to get better and better and better. Now if I shock the system one more time, click it on and off, it's going to knock these air bubbles around the tubing, which should be able to help spit some of these out into the reservoir. Okay, I'm going to do it again. And by shocking this, by kicking it on and off, what it's doing is it's just moving those air bubbles out, helping to bleed system out. Now look at the water starting to get a little bit more aggressive. I'm going to do it again. There we go. Now look at that. Now we've got some really, really good water flow. And if I look down at my tubing, all my air bubbles are gone. So that's where we want to be with this thing. Now I'm going to show you the actual, this is where your noise is coming from. So what I'm going to do is I'm going to cap that. And I want you to listen to the pump. This is full on. And my microphone is maxed out. So that's as loud as this pump is going to get. Now in comparison, I've got a Noctua silent fan here. I will plug, quote unquote, silent fan. I will plug it in. And I will position it so the air is not blowing on the microphone. And now you can hear that. That's a case fan. Then 3 or 4 feet away you really can't hear it. But with the microphone right up to it, it sounds pretty loud probably. And there's your pump. And there's your reservoir kind of gurgly. But yeah, it's quiet. So that's about it. Once you get the air out of there, you're good. You can top off your radiator and you're done. Okay, I hope that covers everything. I don't think I forgot anything. Oh, yeah, no, that's it. You got the cleaner, the grease, the coolant, the pump, the tubing, you're set. Should be no problem, and I'm really happy with what this pump is doing. It's putting out a ton of water, so you should have no problem with this one, Grant. All right, that's it. Bye.